Okay, so today we are going to start the unit number 6, that is PIC 16F877A core feature. So in brief introduction, we have already discussed all the points whatever it is included in this unit. So core features, it is nothing but the internal structure of the this particular PIC. So my basic session or the this is going to be start with the syllabus for this particular unit, and from that whatever the red marks I have made, so that we are going to trying to complete it today. So it has the functional pin description, then program memory and data memory, then various registers, that is GPIO and SFR, then IO port configuration, then interrupt, and then various kinds of reset. So these are the few points from this unit. So first point, that is the functional pin description. So it is already we have covered in the fifth unit की प्रत्येक पिनचं फंक्शन काय आहे आणि ते कशा प्रकारे वर्क होतात, कशा कशासाठी त्याचं फंक्शनिंग आहे. त्यानंतर प्रोग्राम मेमरी and data memory. We are familiar with that the two words, data memory and program memory. So what is the program memory? If you are comparing with the 8051, so it is the ROM, and data memory, that is the familiar with the name of RAM. So in this PIC, how many memories are present and how it is going to be used, so that we supposed to check out under this. After that, the various registers, that is GPIO, that is general purpose input output register, and SFR. SFR stands for special function register. So which are the SFRs available here? What are their functions? So that we supposed to check out under this GPIO and SFR. Then IO port configuration. So as we are knowing that the how many ports are there for PIC? Answer is 5. So which are they? What is their capacity? So all we have seen. So that also again we are going to learn how to configure them. That means I think in practical time only we have seen that ki how to decide their direction. Direction means इनपुट म्हणून वापरायचंय का आउटपुट म्हणून वापरायचंय. जर इनपुट म्हणून वापरायचं असेल तर कसं इन्स्ट्रक्शन किंवा कमांड लिहायची, किंवा आउटपुट म्हणून वापरायचं असेल तर कशी कमांड लिहायची. सो दॅट in that way only how to configure that port, that we are going to learn. After that, interrupt. So if you are remembering for 8051, there were the 5 main interrupts were there. तसेच पिक मध्ये किती इंटरप्ट आहेत, कुठले कुठले आहेत, इंटरनल एक्सटर्नल. So that we supposed to just learn under this interrupt. And the last point, that is the various kinds of reset. आता स्पेशली रिसेट साठी आपण बघितलंय की ब्राउन आउट रेजिस्टर किंवा वॉच डॉग टायमर. तर अशा प्रकारचे जे सर्किट्स आहेत तर ते कसे वापरले जातात आणि कसं रिसेट होतं. ऍक्च्युली सर्किट it consists of resistors, switch, capacitors. So how it is going to use for resetting the PIC. तर त्या सर्किट डायग्रामचा स्टडी ह्या व्हेरियस काइंड्स ऑफ रिसेटच्या अंडर आपल्याला करायचा आहे. So first point we will go with that the functional pin description. So let us go with that start with the quiz. So just I thought in the morning only that we are going with the PIC, but whether the students are remembering or forgot the long form of this PIC. So this is only I have added over here. So can from the boys I am expecting the answer for this, and if it known to the boys, so you can just put in the chat box. So anyone ready to give the answer for this? As usual, the bully or the girls has started to give the answer, but from boys side it was expected. So the long form for that, you are going on the Google and just trying to search and then giving the answer, so that is not at all expected. At least what we are going to learn, the total second section is the pick only. So this is the peripheral interface controller. So this is what the answer for this pick. So those the boys, yeah, not expecting from your side that. Let us see those who are having the any problem. So just be attentive now onwards, at least for each lecture and for the revision lectures also, or the defaulter lectures also. Okay, okay, fine. So we will go with that the particular the functional description. So this diagram or the slide already I have shown to you in earlier sessions, which shows the various ways or the various functions of the pick for which it can be used, and the respective colors also I have just given so that they can be grouped. That is, for example, C1 out, C2 out. So that is for the this C1 C2, it is green. Then for timer it is dark green, it is been shown. Then violet, this color it is given to the I2C. So what is this I2C? So separate point is there in the coming units I2C, but at least long form we have discussed. So anyone is remembering I2C? I2C, it is actually IIC. I square C it is actually. But somewhere I2C it is written, somewhere IIC written, somewhere like this the I2C is written. So it is inter integrated circuit. Inter integrated circuit. So what is this type of circuit? And these two violet colors, two pins are dedicated for that. So what is their use and their function? So in coming unit we are going to learn. For SPI, that is serial peripheral interface. So for serial communication it is used. So for that that brown color it is being shown, that is SDI and SDO, that is serial data input, serial data output. So, and on the left side also SCK and SS. So at different places these different pins are allocated. So how they are going to use and their function, so that we have to learn in coming units. Then yellow color, that is PGD, PGC, PGM. So that is also used for the interrupt related. So 33 pin is also dedicated for external interrupt. So in that way it is grouped the functions of this pick. Then this PSP 0 to PSP 7. So at different locations the pins are there. They have not consecutively or the continuously they have provided. Two pins on left, two pins down right, then four pins upper. So in that way these pins are allocated. So this, what is this PSP? That is parallel serial port. So that also it is going to use for the parallel communication. So that time how it is going to be happen, so that also we will just learn in the coming units. Then clock, dark brown color it is been shown, that is for the clock. So clock it is nothing but the external clock. That means we can attach the external crystal oscillator there. Four modes are there. That also we have seen in the configuration bits or the configuration word, if you are remembering. And in that the how to set the configuration bits. So during that practical time we have seen already. That is how we can set on off the watchdog timer or the other brownout this timer. So how to make on off, that all we have seen. Okay, that is pin number 1. It is not shown over here because that is having the fixed function for that. That is for the resetting purpose. So that is also there. So main highlighted over here, that is the RD, WR and CS. So they are nothing but the control lines: read line, write line and chip select line. Pin number 8, 9 and 10. So in this way, this is what the all this grouping is been done, and you supposed to just concentrate. This is a very important diagram, and for that only I have prepared this particular color grouping. About the, this is all about the functional configuration about this PIC 16F877A. Okay, so this is what we were talking about, that the direction register. So just see the table carefully. So 5 ports are there as we talked: A, B, C, D, E. Their direction registers are TRISA, number of pins, and their alternative function, because in this PIC the same pin is used for the multiple functions. So what is that alternate functions are there? So that is shown in this particular table. So it is also very important table for us. So direction means key, it is a input or output. So TRIS, what the I told the long form for that, that is tri-state. It is the tri-state. And lastly A B C D E. TRIS A B C D E. That is the port name. Like this it is there. So each port is having the capacity of or the number of pins or number of bits. So they are given in this third column. So that is PA0 to PA5. So total 6 pins like this. After that, port B 8 pins, port C 8 pin, port D 8 pin, port E is having only 3 pin. PE0 to P2. It is wrongly placed over here. PB2. So it is PE2. So I will make that correction and I will share this PPT. But right now also you don't get confused over here. So PE0 to PE2. So which are these 3 pins? So if you are looking over here, so RD, WR and CS, they are comes under this particular port E, that is control bits. So they are also the function of this control bits in this port E. So the total 40 pin out diagram, if it is there in front of you, you just see there, so that you will get clear that what are the alternate functions of this particular port A or port E. So this is also very important for that the registers as well as the number of ports, their capacity and the various their alternate functions. That is this I2C, PWM, interrupt, ADC, that all one by one in the coming whatever the 2 units are remain. So in that it is explained. So that we are going to learn in that. So this table is only we are going to learn in this section second. That is registers, the ports and the alternative functions. Okay. So Going ahead with this, so this is the whole diagram or the architecture or the structure of PIC 16F877A. So just look at this. So you will feel that how complicated it is, but no, just try to make a grouping here also, so that you will remember all the things whatever the PIC has. So main the center part, that is CPU. CPU, it is connected with the registers and the configuration bits. Power up timer, the power on reset, watchdog timer, brownout reset, in circuit debugger. So it is directly connected to the this CPU. With that, the ports, which ports are there? So actually here D to A converter they have shown, but for our PIC it is not there. Our PIC means 16F877A. The general block diagram I think they have given of a modern PIC. Modern PIC. So I have just copied from there. So we remember that D to A converter, it is not there for 16F877A. A to D it is there. Three timers are there. The ports they have shown, it is the only two ports. So here five ports are there. So this is the general diagram of PIC it is shown, not specifically the our 877. So which registers are there? So accumulator it is replaced by the W. So that also we have seen, that is tri-state register, other RAM registers. So that we are going to see. In addition to that, the other functionalities comes over here. That is comparator is also there, USART is also there, CCP modules are there, serial parallel ports are there. So they all are there with our 16F877. So this is also the called as the functional diagram. It is a general diagram, so you can just draw or remember the specific this architecture from our earlier lecture on the last unit first. That is the architecture of PIC 16F877. Don't compare this slide with that one. So there we have shown the exactly for 16F877. This is the general architecture. But which are the functional blocks are there? So for that sake only, I have just taken this slide. How many types of memories are there? So it is mentioned over here: RAM, ROM, and flash memory. So three types of the memories are there. So that also in coming session today we are going to learn that only. That is the this block we are going to study today. That is memory. So afterwards you just noted down this diagram or the other functions from this. So now we will go to the next point, that is the memory. So the memory of this 16F877, it is divided in the three sections. That is program memory, that also known as the ROM. Data memory, that is also known as the RAM. And EEPROM, that stands for the, or it is also known as the flash memory. That is temporary memory. So in that way it is going to be divided. This the three types of memories are available in this particular 16F877. Now next, what is the program memory and how it is there? So how it is going to work? So that it is mentioned over here. So program memory, the basically the use is whatever the user is writing the program or the code, that is going to stored in this program memory. That is the program counter. That is one of the parameter in this PIC, which instruction by instruction it is going to compile. It is executes this particular, the program counter executes this stored command one by one. So what is the size of this particular instruction set? So it is the 13-bit program counter is there. 13-bit means 2 raised to 13. That many instructions we can give, or we can store in this particular program memory. So 13-bit wide means the total it is having the addressing capability of 8K. That is 8 kilobyte. 8 KB is the size of ROM in 16F877. Just note it down. That can be asked in the MCQ. Then this particular memory that is primarily used for storing the programs that are written or burn. So the burning means not actually burning. So burning, it is nothing but just whatever you have written the code in computer, that you are going to transfer to the actual PIC. Actual PIC means PIC is nothing but IC. PIC is nothing but IC. आणि त्या IC मध्ये तुम्हाला तो प्रोग्राम ट्रान्सफर करायचा आहे. That is known as the burning. Got it? So this is the use for this particular program memory. And how much is the program memory is there? So that is we now known. This is what the strategy of using the program memory it is given over here. की एखादी इन्स्ट्रक्शन्स लिहिल्यावर टोटल मेमरी मधले कशी ती इन्स्ट्रक्शन फेच करतो आणि कशी ती इन्स्ट्रक्शन एक्झिक्यूट होते. So that is shown over here, that is program memory map and the stack. So the concept of stack in the 8051 is also there, and your data structure, you might be studied this subject in the earlier year. So there it is also there. So stack, it is nothing but a buffer memory in which the instructions can goes one by one and first come first serve. In that way the instructions are going to be used. So sometimes the last in first out, that instruction also strategy can be used. So how this particular stack it is being used, so that is used for that as a buffer, because sometimes the speed of this particular execution of the instruction and reading or the fetching of the instruction that not matches. So that time this stack memory it is going to be becomes the very helpful. Okay, so in that also the address 0000, so that is by default, or it is a fixed as a reset vector. So if you always the program whatever you are going to write, it is going to start from the address 0000, and the address 0004 it is reserved for ISR. So ISRs are nothing but the interrupt service routine. So what is the contents of this ISR? So in coming sessions we are going to learn. कारण ISR ला 0004 हा ऍड्रेस असाइन केलेला आहे, परंतु त्याच्यातल्या ज्या बीट आहेत 13 बिट्स, मग प्रत्येक बिटचं फंक्शन काय, कशासाठी हा ISR वापरला जातो. सो डेफिनेटली इट इज रिटन ॲज अ इंटरप्ट. सो इट इज रिलेटेड विथ द इंटरप्ट. मग इंटरप्ट इनेबल करायचा का डिसेबल करायचा, मग इंटरप्ट इंटरनल घ्यायचा का एक्सटर्नल घ्यायचा, इंटरप्ट किती वेळासाठी घ्यायचा. सो इन दॅट वे ऑल दिस बिट्स आर हॅव्हिंग द फंक्शन्स. तर मग प्रत्येक बिट कुठल्या कुठल्या असतात ह्या ISR मध्ये फील्ड मध्ये. That is the name of each field that we are going to see in the coming session. So this is about the program memory. Similarly, the next, that is the data memory. Similarly, it is having the data memory. Data memory म्हणजे काय की ज्यावेळेस तुम्ही प्रोग्राम एक्झिक्यूट करत असता आणि काही डेटा तुमचा असतो 2 + 3 = 5, त्यासाठी तुम्ही प्रोग्राम लिहिलेला आहे. परंतु जर युजर कडनं तो डेटा घेणार असाल की एंटर द नंबर्स, दॅट इज 2 3, आणि यू सपोज टू स्टोअर द आन्सर 5, So that time this temporary memory, that is the RAM, is going to use, and that is also known as the data memory. So this is what the in PIC it is separated into multiple banks. जर तुम्हाला 8051 आठवत असेल तर 128 बाईट 128 byte was the memory for RAM. But here आणि तशीच 128 plus 128 होती जर आठवत असेल तर, की 128 it is for general purpose आणि additional 128 for SFR. असं डिस्ट्रीब्युशन त्या 8051 मध्ये होतं. In the same manner, in this PIC, there are 4 bank. Bank 0, Bank 1, Bank 2, Bank 3. त्यांनी हे रजिस्टर डिवाइड केलेले आहेत, ग्रुपिंग केलेलं आहे. आणि प्रत्येक बँक मध्ये काही जागा जनरल पर्पज साठी रिझर्व आहे आणि बाकीची हे जे दिसते सगळे 1 2 3 4 5 दे ऑल आर द SFR, स्पेशल फंक्शन रजिस्टर्स. प्रत्येक बँक मध्ये हे जे दिसतंय TMR 0, PCL, स्टेटस, FSR, पोर्ट A, पोर्ट B, सो दे ऑल आर द FSR, special SFR, special function registers are there. And this is what it is written over here. It is separated into multiple banks that contains the GPR and SPR. Actually it is SFR, not SPR, SFR. So that again the one correction. And this according to that the 4 banks are there and each bank hold 128 bytes. जर तुम्ही साइज बघितला तर इट स्टार्ट्स फ्रॉम 00 to 7F. So 7F means 0111 1111. Got it? And that stands for the 128 bytes. And if you're observing in all these 4 banks, first 32 later locations from bank 1 and 2, as well as first 16 locations of bank 2 and 3 are reserved for mapping of SFR. म्हणजेच 00 to 1F हे सगळे SFRs आहेत पहिल्या 2 बँक मध्ये. आणि तिसऱ्या आणि चौथ्या मध्ये फर्स्ट 16 लोकेशन्स म्हणजे 100 to 10F म्हणजे 0 to F, दॅट इज 16. तर बँक 2 आणि बँक 3 मध्ये पहिले 16 लोकेशन्स हे SFR साठी रिझर्व आहेत आणि त्याच्या पुढचं जनरल पर्पज रजिस्टर साठी. तर असं हे रॅमचं डिस्ट्रीब्युशन पिक मध्ये केलेलं आहे. तर आता हे प्रत्येक SFR कुठले आहेत. सो इन नेक्स्ट सेशन वी आर गोइंग टू लर्न दॅट दिस पर्टिक्युलर इम्पॉर्टन्स ऑर द फील्ड स्पेसिफिकेशन्स ऑफ दिस ऑल, दॅट इज PIR1, PIR2 सेमच असतं, परंतु हे PIR म्हणजे काय हे ऍटलिस्ट आपल्याला माहित पाहिजे. So that we are going to see. So this is the overview of this particular data memory, that is the RAM. So each bank is having 128 byte. म्हणजे total RAM चा size किती झाला? So that you can calculate from this one, that is 00 to 1FFH. So this is the RAM size for this PIC. आता ही कुठली बँक चूज करायची. सो इट इज डिसाइडेड विथ 2 बिट्स, दॅट इज RP0 आणि RP1. ते कुठल्या इन्स्ट्रक्शन्स मध्ये आहेत. सो इन कमिंग सेशन वी आर गोइंग टू लर्न दॅट ऑल्सो. बट हिअर यू जस्ट ट्राय टू रिमेंबर दॅट ऑन दिस, नोट इट डाऊन दॅट RP0 आणि RP1 ह्या 2 बिट्स असतात की ज्याच्या कॉम्बिनेशननं बँक सिलेक्ट होते. बँक सिलेक्ट होते कारण प्रत्येक बँकमध्ये मल्टिपल ऍड्रेस आहेत. त्यातला जर तुम्हाला हा पर्टिक्युलर T1 कॉन रजिस्टर सिलेक्ट करायचा आहे, मग इथं सुद्धा 10 आहे, इथं सुद्धा 90 आहे, म्हणजे 10th लोकेशन आहे. तर मग बँक 0 मधलं घ्यायचं का बँक 1 मधलं घ्यायचं, हाऊ टू सेट दॅट. सो दॅट इज डिसाइडेड विथ दिस 2 बिट्स, दॅट इज RP0 आणि RP1. सो दॅट वी सपोज टू जस्ट रिमेंबर. The third type of memory, that is the EEPROM, that is flash. That is फ्लॅश. सो हे कशाला दिलेली आहे? दोन मेमरी तर आहेत, रॅम रॉम. सो इट इज द ॲडिशनल मेमरी इट इज बीन गिवन, and that is what flash memory. It is readable and writable during normal operation. म्हणजे ज्यावेळेस एक्झिक्युशन चालू असतं तर त्यावेळेस ही रॅमला मदत म्हणून ही फ्लॅश मेमरी वापरली जाते. दिस मेमरी इज नॉट डायरेक्टली मॅप्ड इन द रजिस्टर फाईल साईज स्पेस. म्हणजे त्याच्यासाठी सेपरेट लोकेशन्स किंवा ऍड्रेस असा नाही दिलेला पिकमध्ये, कारण रॅमला सपोर्टिंग म्हणून ही मेमरी तिथं ऍड केलेली आहे ॲज अ बफर म्हणून. इन्स्टेड इट इज इनडायरेक्टली ॲड्रेस्ड थ्रू द SFR. जर गरज लागली तर SFRच्या थ्रू ही मेमरी वापरली जाऊ शकते. तर सगळेच SFR का? कारण इफ यू आर लुकिंग इन दिस डायग्राम, so many SFRs are there. So not all the SFRs are using this flash memory, but few particular SFRs are there which can use this particular flash memory. That is EECON, EData, EADR, EADRH. So these 6 SFRs only can access the flash memory. So at the same time, whatever you are writing in the data, this flash memory, this automatically erase location and म्हणजे जर पहिला काही डेटा तिथं अवेलेबल असेल तर तो ऑटोमॅटिकली डिलीट होतो आणि नवीन डेटा तिथंच पेस्ट होतो. त्यामुळे ही मेमरी खूप लहान ठेवलेली आहे ह्या पिक मध्ये. Got it? So this is what the third type of memory, that is electrically erasable, programmable, read-only memory. So this is all about the memory organization in the PIC 16F877A. So in the next session we are going to start, that is this register memory organization. म्हणजेच जनरल पर्पज IO आणि SFR त्याच्याबद्दल आपण बघणार आहोत. So today we will stop over here. Now you can just put the attendance. Don't forget to put your name in the attendance and you can leave. Thank you.
Hello, sir.
Who is there?
Sir, Abul.
Okay. Hi Abuli. बोलो.
ते कोर्स पण स्टडी मटेरियल मध्ये ऍड करता का?
काय ऍड करता का? नाही समजलं.
कोर्स ते MP लॅबचे.
MP लॅबचे कोड.
ते LED ब्लिंकिंग ते.
ओहो, मग ते ऑलरेडी केलेलं आहे ना हो. जसे आपले म्हणजे तुम्हाला सेपरेट वर्ड फाईल हवी आहे का? कारण ते व्हिडिओ तर अपलोड केलेले आहेत आपण प्रत्येक.
सर व्हिडिओ मध्ये काय होतं ते दिसत नाहीये, ब्लर दिसतंय सर.
ओके 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 ठीक आहे ठीक आहे ठीक. चालेल, मग प्रॅक्टिकल वाईज सगळे जे कोड्स आहेत ते एका खाली एक लिहून एक वर्ड फाईल तयार करून आय विल पेस्ट मॅडम.
थँक्यू सर.
ओके, थँक्यू मॅडम.